Okay, I thought I'd show a little bit about how I line up on this part here to begin the first milling operation on it. Now I've already indicated it down at this end here on the chuck, and I've showed that many times in videos, so I'm not going to show that again. I just indicated it in so it's running concentric down at that end, and I've got it on the steady rest here, and this is running true. And also I've indicated up and down the part lengthwise to make sure everything is running straight, because it is possible to have it running true down there and here and be off at an angle. So you got to make sure that's not so. So now what I do is I've marked, this is a hole that I'm going to use to reference my C-axis rotation on here. And the first thing I got to do is make sure I'm centered on the end of the part, because this can sometimes vary a little bit, not very much, but a little. So what I do, let me get this back here a little further, is I got to run the machine to the XY center point. I'm just jogging it with the hand wheel right here on the control. So right now I'm at the center point, and I've got to make sure the spindle's unclamped so I can rotate it here, which I can. Now let's see if I can get a little bit better angle on the camera here. And what I want to do is actually, it's important on this kind of a machine. I'm going to bring this in here and set my indicator to rotate the C-axis while you indicate your center line here, because you can have a slight, say this stock isn't round or something, and I just rotate around like this, I could be off center in relation to the rotation. So it's better to mark something on the part. Like I've marked this hole that I want to indicate a little bit later, and I'm going to rotate the C-axis around like this, and then I've got to jog the machine to the center line. Let me see if I can get the camera in a little bit better location here for this. Okay, so when I rotate it around, now you notice that I've got to move up about 1/1000th of an inch here. This sometimes varies a little bit from when you, because the machine was shut off last night, and I'm just turning it on this morning to indicate this part in, and the way this steady rest clamps down or something can be slightly different, or just the fact that the machine is at a different temperature can even make a difference. So I like to indicate this in every time, although it's probably not enough off to really matter, but I just like to make sure. And you can see, I'm going to re-zero the indicator here just a little bit. You can see it's on 0 here. I don't know if you'll be able to see this in the video, but if I actually just rotate around, you see it's off here by 2/1000ths, a little over 2/1000ths of an inch. But if I actually rotate the part around, you see it's on 0 here. See, so this is the error you can get into with one of these multitask machines. If you indicate just by swinging the indicator around the part like this, you can actually be indicating some kind of other run out that you don't know about unless you rotate the part when you indicate it. This is something I had to learn by trial and error, actually. Our Y needs to be moved just a little bit here. And rotate the part back around. Now you see that the indicator's on 0 up here, because there is some kind of a little slight run out. It could be that the part's not straight in the middle, and it's got a bow in the middle, and it's causing this end to run out in relation to these rollers on the steady rest over here. And you have to be careful about this, or if you just have a part chucked in the chuck without the steady rest, this can happen too. If your part's not perfectly square coming out of the chuck, and you just swing the indicator around it like this, you can have a problem with this. In fact, you can see it happening right here. See where it's 2/1000ths difference on the bottom than the top, except when I rotate the part itself. And now I'm on 0 all the way around. See, if I follow that mark I made, I'm very close to it. For this purpose, it's close enough. So now what I'm going to do is zero my X and Y, X being this way on this machine, and Y being, I don't know if you can see me, across this way, and X is up and down. I'll zero my X and Y out, and then I can set my C-axis rotation on this hole that I've determined the location of here, and set 0 and X and Y. I'm going to do that on two. I'm using two different fixture offsets on this program, so I have to set both of them at this point. Back this off, and I know that this hole right here, I want to come up 2 inches 61 thousandths for this hole in the X direction, and the Y direction on this particular hole is minus 2/1000ths is what I've determined from the CAD model, the location of this particular hole that's drilled in here. Now, the drilling people have a tolerance on these, and so here again, this might not be perfect. So you kind of got to use your judgment here on what you think is right and what isn't right. Now, I just kind of roughly set the indicator here, because when I rotate the spindle, you're going to see right now that it's off. Let me move the camera maybe a little bit here so you can see this better. You can see it's off. It's way, when I rotate around, I set the indicator over here, and it's way off. But somewhere in between there is the actual place we want to be on the C-axis. So I'm gonna jog that over a little bit here, where it's about on the same place on either side here. I'm not going to worry about the indicator being perfect just yet. I'm going to readjust my indicator a little bit, but I'm not going to put it in the hole. I'm just going to get it better if I can here, where it's running more in a circle. I'm going to jog the C a little bit more this way. Now I can jog in there a little bit, but not necessarily touch my indicator on anything. But I don't know if you can see that. It's kind of hard to show this on the video. If I can maybe get this in a little better position. Maybe that'll be a little better. See, I'm still just looking at the way this stylus is in the hole here. See, it looks like the part's still got to rotate a little bit more this direction. So you're just getting a rough adjustment, say, if you will, on where you think your hole might indicate. Once you get it pretty close, then you can actually stick the indicator on here and set some kind of a deflection on it. Not too much, because you could run out of travel on this kind of indicator. So that you can see here, I've actually rotated it a little bit too far. I'm going to set this on the minimum rotation. I'm going to come back up to 0 here, because my zero was more or less correct up and down. It's not exactly right. But what I'm trying to do here is set the rotation of the C-axis. I'm going to actually jog the indicator a little bit further up in the hole here, because sometimes these holes have a little bit of an imperfection right on the ends of them, and I want to kind of get around that. So right now the indicator is not even being touched, and here I'm going to set a little bit more deflection on the indicator now, just by pushing it over. And I'm going to re-zero it here. I'm going to rotate around here and jog my C-axis halfway between there somewhere, like something like that. Re-zero the indicator and go back over here. I can already see this hole isn't in the most ideal location. You see, up and down in the X direction, it needs to be, I need to jog the machine a little bit. Okay, now I'm pretty close. See, these holes have, the drilling shop has a tolerance here, and so the holes can be a little bit off, and you kind of got to use your judgment here. And generally what I like to do when I'm indicating something that rotates is, I'm not too worried about the up and down, because that doesn't change my rotation very much, but so I don't change my y-axis position, but I tend to move my x-axis, in this case, up and down here, this direction, to get lined up on the hole, but I don't move my y-axis direction, because this is going to change the rotation of the part a lot in the y this way in this machine, but x is not going to, I can move it an awful lot and it's not going to change the angle too much, so I don't worry too much about the X being perfect. I have to jog it to where the location of the hole is to line it up, and then I rotate around until I can get my C-axis rotation without changing, like I said, the Y to indicate on 0. Okay, so that's pretty close right there. And actually I only moved the X-axis a little bit more than 1/1000 of an inch to get this lined up. So I'm not too worried about that. That's well within the tolerance the drilling people had to use. So now I can set my C-axis 0, which will set the rotation 0 of the program here. Here we are looking at the controls monitor, and see, the original y-axis setting has not been changed. It was -0.002 for this hole, but the X should have been 2 inches 61 thousandths. See, so it's 1.1 thousandths difference. And like I said, I'm not too worried about that, so I'm just going to let this go like that. If I move back a little bit here, I got to go on this control to, I'm looking for the work offset key here. Go there, and then this is the C-axis offset right here that I want to change. So I'm going to run my cursor down to it, and I'm going to just go teach 0, which is over here. I don't know if you can see that over here, and then push input, and it's going to set that 0. And I'm going to go down here. On this, I'm using these two fixture offsets, G54 and 55. I'm going to use 54 for the end of the part and G55 for everything on the OD, because this can vary a little bit in the Z offset. So I use two different fixture offsets, and the Z and the X as well. So in this case, I'm going to go teach 0 again for this C rotation. So if I go back here to the display, it's not going to have updated it yet until I hit reset here, and now it says C0. Let's stop right here for a second. I noticed I made a mistake when I was reviewing these video clips. It's a small mistake, very small error, but an error nonetheless. I left out a step when I was busy making the video clips. If you think you know what the mistake is, leave it in the comments. So that's how I set the fixture offsets on this, except for the Z. I have to put the Hamer probe in here to set the Z. And I'm going to pull this away, and then on this machine, in order to extract the tool out of the spindle, I have to orient the spindle on this. That's just, I guess they do that as a safety procedure or something like that. I'm going to get the hammer probe. It's the way I set it on this machine. Just easier than trying to use a spindle probe or something like that. I'm going to come down here closer to the center, or where this hole is going to be, and I'm going to set the so I'm going to jog this up to 0 on this probe. At the machine, and I'm going to look for the work offset key again here. Go there and set it on the Z of the first fixture offset and say teach 0. And then I'm going to go down here to the second fixture offset and teach 0 again. And we're going to go back to the input screen and see it's saying it's 10 thousandths. This is a different piece of material, so it could vary. And if I hit reset, now we're at Z0 here. So that's how you set the fixture offsets for this particular part.